Wait.
Birthday to you.
Happy birthday to you. Happy birthday, dear Sarah.
Happy birthday to you.
Do you want a cupcake?
Thank you.
Ooh, I don't have a muffin.
It's Sunday, by the way.
I normally have a muffin with me.
You don't have muffin? Oh, thank you. I appreciate the thought.
Yep.
I did get a milkshake. It brought all the boys to the yard.
Okay, guys, let's get started. So, we'll start with partial derivatives. Yeah.
It's live. We're live.
Technically, people can go and watch it live, I think.
Oh, you stream
I think it does do it like live on YouTube if you like search it. So our z is equal to 9 minus
Can I watch myself on TV?
x squared minus y squared. So we have a function consisting of two variables, right? We want to take the partial derivative of z with respect to x, okay? Now it's not a full derivative, it's like a partial derivative. So what that means is you keep essentially you keep the other variable as a constant. So in this case, when we're doing the partial derivative with respect to x, we treat y like a constant. Okay? So what would the partial derivative be?
2x.
Negative 2x.
Ooh, he burned you. You're right.
Oh, those are your D's. Okay.
Like, it's not a d. Like, this is a d for a derivative.
I guess the lowercase delta.
Okay? This is like a curved d, or like it's like that. I thought delta was,
Maybe I just don't know.
it's like a cursive d. So
Oh yeah, it's not a lowercase delta. It's
So
close.
that's the symbol for it.
Dr. Tyler said it's early D.
Early d. Okay.
Is that really the name for it?
No, he just said that.
This is also the same thing as the derivative of the f function with respect to x. So we write a little x on the side. That's another way of writing it. Or we could say the partial derivative of f with respect to x, because the function f is equal to z in this case.
It doesn't actually have a name.
So what would the partial derivative of z with respect to y be?
Negative 2y.
Yep. So that's like the most basic you can get with it. So this would be f of y.
It says you could call it del d partial curly b, or my favorite, dabba. Dabba. Dabba.
And then you can have more confusing functions, so you have to be careful with those. So, but okay, this is now a good problem.
Oh, happy birthday to
So
can also be called a dabba. What? Yeah, you can actually make 5 name for me.
So is it
all right, guys.
Are those D's?
Dude,
This is a full derivative. It's not a partial derivative. Okay. So what is the full derivative of this?
The product.
3y squared.
The product.
Squared
Yeah, 3y squared x squared
plus 2x y. Yeah, y cubed.
y cubed.
Forgot something.
Y prime.
Oh yeah.
There you go.
Who burned?
Times y prime.
I did.
So the partial.
So let's do the partial derivative of it with respect to x. Since we're doing it with respect to x, what do we hold constant? Y. So what would the derivative be?
2x. Oh,
2x y cubed. Because this is treated like a constant, just like a 2.
so can't.
So you still need to multiply with it, okay? Because if it was, say, 2 squared times 3 cubed, I mean, you'd still have 3 cubed, right? So you treat it just like a normal constant. Now, the reason when we had before, like, x squared plus y squared, that if this is a constant, the derivative of that is 0. That's why there's no y term in the answer. And in this case, though, both x and y are independent variables. And we're keeping y constant. So now we're doing the partial derivative implicitly. So let me write out this stuff. So on the exam, they will ask you to do a problem implicitly. And then, have you guys learned the formula? Negative fy over fx, something like that? They mentioned it or something?
I think you write it down.
Yeah, we wrote it down.
Okay. So this is doing it without that formula.
When they say like,
Taking a partial derivative implicitly. You were saying something?
when they say use the chain rule and use the, like which one is the cap one way, which one is the new way?
This would be the chain rule way, I think. Is
The
that
new way is the chain rule way?
what do you mean the chain rule? There's the chain rule way or the tree way, right?
She's talking about the chain rule where it's like, you have the constraints, you have to do the F of.
Yeah, that's something else. Yeah.
Oh.
This is taking the partial derivative of z implicitly. Let's just go and then we'll
Okay.
understand it.
Later.
So partial derivative implicit of z, and we are given x, y, z plus z squared plus z times the natural log of x equal to 5. So we need to find the partial derivative of z, right? That would, what would that look like? Or z prime, which would also be equal to with respect to x.
You can write Z prime. That's
Yeah.
why even though the partial-
Wait,
Yeah, but in this case, all the derivatives will be partials because there's no way to do a real full-on derivative of it since it's like equation like that.
sorry.
So they'll give you the.
So essentially they're telling us to find this. That's all you need to know.
And they gave us that equation.
Yeah, they gave us
Give
that
the
equation.
Z prime or we have to find ourselves.
We have to find that.
Is it just x,
Okay.
y plus 2z plus z?
No, hold on.
And
Now, since we're doing it with respect to x, what will be constant?
All the other variables.
wait,
Y.
What? Whoa,
Y not X
Whoa, watch
or
out.
Z.
back up. So.
Okay, we're
whatever
taking the
is-
partial derivative with respect to x, right?
Oh,
Yes?
okay.
If we're doing this part with respect to x, there's another variable y here, right? But we're going to treat it constant.
Is
Are
Z
those
prime-
your doves? Whatever they are, right?
Yeah, the partial derivatives.
So there were twos, devos.
Oh, you think they're twos? No.
Mine look like two.
I'm sorry, Daniel. I was just like,
Sorry.
I was like, why did you not cancel the twos?
So is anything that's not in the numerator or denominator but partial constants, like z and x aren't constant, but y is?
Since we're taking it with respect to x, we make everything a constant.
Besides x?
Yeah, like we were
Oh.
doing, say, x squared y cubed, and we're doing it with respect to x, right?
Mm,
Since we're doing it with respect to x, we treat y cubed as a constant. Okay?
dy over dx, y is a,
So why? would
dava,
they do
y
that?
over dava.
Yeah, this is partial derivative. So then this would be 2xy cubed. That's what we did, but we treated this as a constant. Okay?
Dude, your twos and
Your dad listened to twos look exactly the same.
No, they don't. Just like.
Okay.
So sorry.
Oh wait,
I will-
is that a dava?
No, this is a 2.
It's like you
What's
gotta pick
the-
some
what are the
examples that
other
don't
ones?
have twos.
Those are
These-
davas?
Yeah.
Oh,
The
no.
partial
those look the same. I
derivatives.
thought that was 2 times.
Oh,
You need to extend the arc of your dava.
let's.
Yeah.
Okay, I'm gonna try to write 2's like that.
Yeah,
Okay?
awesome. Thank you.
For, and then if I don't, remind me.
It's like for some reason so many twos.
Okay?
Oh my god, I'm interested.
Now, you have a question.
So when you take the derivative of the equation on the right.
Yeah.
Is it gonna be,
With respect to x,
so, okay, I think I understand. Let's just do that.
okay.
So this is it.
So then, since we're doing it with respect to x, this is essentially equal to taking the derivative, partial derivative with respect to x. And then this is how we write the variable that's going to be constant.
So z is a constant.
Right.
We're taking it with respect to x. It's like taking the derivative of x squared, y squared plus z squared, I don't know, equal to 5, and finding y prime.
So you still leave it as you would like do a dz over dx.
Like this is finding y prime, right? Which is derivative of y with respect to x.
Yeah.
So it's like that. So let me erase all of this. And then we can rewrite the whole thing. We could write it as taking the partial derivative of the entire thing, right? But that's the same thing as doing the partial derivative of each part. So the partial derivative of xyz plus the partial derivative of z squared plus the partial derivative of z natural log of x equal to the partial derivative of 5.
Where'd you break it up?
wait, so
I mean, it's the same thing. This just makes the work easier.
are we taking the partial of, we're taking it respect to x, but
Of the entire
can we
thing.
say that y
is constant.
is constant and z is still differentiable? Like,
Yeah.
How do you
Then-
tell apart, like, if I just look at that, I'm just gonna take the partial with respect to x, and I'm not gonna mess with, like, I'm just gonna use z as a constant.
You don't use z as a constant, you use y as a constant, right?
How can you tell, just looking at that?
Because we're doing it with respect to z, and it's a partial derivative.
But that's
Did you-
just like-
Yeah, no.
Yeah, I mean, sorry, we're doing it with respect to x, and it's a partial derivative. That means we don't mess with the y. And since,
What about the z?
How do you know not to mess with the z?
Yeah.
because we know the problem asks us to find dz dx.
So should we write down, partial, the dava z, dava x?
Like, I erased it, but you know that's what we're trying to do.
Okay,
So it's like almost exactly like doing this. Or something like this, right? And you're trying to find y prime.
Okay.
So then I try to isolate y prime.
So in this case, we're finding z prime. And then
Yeah.
leave the x alone, so only the y is affected.
We leave the y alone since it's a constant. x is not a constant.
Yeah.
Okay, so looking at just y alone, but right now for that, we take out a y because it's a constant, then we can rewrite this, the partial derivative of xz plus the partial derivative, since this has no y term in it, of z squared, plus the partial derivative of the natural log of x equal to the partial derivative of 5, right? So this, I did this to show that y is a constant. Like, you don't necessarily need to show all of that work, but. Okay. Now, is x a constant? No. So what is so y times, what is the derivative, partial derivative of x times z?
Z plus.
Okay, it's the product rule, right?
Because
So- The derivative of the first term, dx over dx times z plus the derivative of the second term, x times dz over dx. Did that make sense? It's the product rule. So with the first term, with the second term. Now we know dx over dx is 1, right?
yes.
So we can leave that answer as that. Now, and right there we found, or we got a term, dz over dx, right? In the end, that's what we're trying to isolate.
So it's like a white line.
It's like a y prime, exactly. Like the derivative of z, or if this were a y, it'd be like 1 times y prime.
Okay.
So that's our first part, plus I think I wrote the problem wrong, but this is supposed to be cubed right here. So this term, what is the derivative of z cubed with respect to x? It's exactly like y prime. Imagine this were a y.
Z squared.
3z squared times z prime, which would be partial derivative of z with respect to x. Does that make sense? You take the derivative of it, z cubed is 3z squared, and then derivative of z with respect to x, like the chain rule. Plus. Now, what rule do we use here again? The product rule. So we keep the. Did this make sense?
Yeah,
Okay.
yeah.
We keep the product rule. First term times the derivative of the second, z. What's the derivative of natural log of x? 1 over x. Plus the second term, natural log of x, times the derivative of z, which in this case would be
Dab is z over dab
partial
x.
derivative of z with
Oh,
respect to
dab
x.
is z over dab x. I haven't gotten to tell Dr. Tyler that this is actually called DABA, and
I'm sure they have a
you
PhD
should
with that.
gotta call it DABA.
So what is the partial derivative of 5?
0.
Oh god.
Oh, you guys do know, like, most of what you guys say does record.
Yeah.
Like, if you watch the videos.
I have.
Watch the time where you like duck down to tie your shoe and put it back up.
Yeah, you're still looking.
It's amazing how much it takes. It's crazy.
Okay,
We're gonna be used to.
so we're trying to isolate this, all right? Like, that's our whole goal, trying to find what this is equal to. So let's take it out. This part here, we can bring it to the other side, right? You guys understand? Like y times z right here. So this, we can have it equal to a negative yz without messing with it, because that's not the term being multiplied to dz over dx.
Oh,
And
it's just a, okay.
and we can also just bring this to the other side. minus z over x. Yeah.
Mhm.
So taking factoring out dz over dx,
Yeah.
we have x plus 3z squared plus natural log of x equal to that. It should have xy. Yeah. Good job.
Get it, Charles.
Because y multiplies to both of them.
You divide it.
In this, we can take a z out. Minus z, so it's y plus 1 over x. Equal to dz over dx times 1 over. This is like, not the right way to write it, because you'd want to simplify it. But since there isn't space on this,
I don't know if you can simplify it that much.
we can do some
Like
stuff.
you when you draw it, like write it correctly, doesn't let you can simplify. You can pull out and see.
You can multiply it x over x, and then it simplifies.
It's honestly like 50-50.
You didn't simplify that, so we know that.
So you can actually multiply the whole thing by x over x. And then I'll give you guys the answer. Okay. So I'm gonna pull this down. So then, in the end, it simplifies. Negative z times xy plus 1 divided by, and then we have extra x being multiplied in the denominator, xy plus 3z squared plus natural log of x.
That's the final answer.
Now, they can tell us to find dz with respect to x at a point. Like they can choose a point and say they chose 1, 4, 1.
But how do you do the natural log? Or is this, well.
Yeah.
We'll get
So
that.
we have a negative 1 times 1 times 4 plus 1 divided by 1 times 1 times 4 plus 3 times 1 squared plus the natural log of 1. So that goes to 0. We have a negative 5 divided by 4 plus 3, 7. Yep. Now, if you were given a point and this is all you did, you might still be wrong because we have no idea whether this point is actually part of the curve. So our equation for the curve was xyz plus z cubed plus z natural log of x equal to 5, right?
Yep.
I mean, if we chose any random 3 points, there's no way for sure saying that is part of the curve, right? Because there's lots of points outside of it. So you have to test the points that Dr. Tyler tells you to make sure that they're still part of your curve, and then you can plug them in. Okay?
Can you read that one more time? Sorry. The curve.
say we chose points 120, 120, 120, right?
Yeah.
And we plugged in those values here, we might not get a 5, so it won't be part of this equation.
Okay.
So in this case, we have 1 times 4 times 1 plus 1 cubed plus 1 times the natural log of 1 equal to 5, right? So in this case, we do get 5 equal to a 5, right? So we know that the point that they told us to find partial of z with respect to x for was part of the curve because it's, the equation is valid.
Yeah.
Let me do that first,
Yeah.
Yeah, you can do it first.
and if that doesn't work, then we just say the rest of the thing.
Yeah, so the reason I did this first is to show you can't just assume and go ahead and plug in those
Are you
points.
sure you just didn't forget to mention it?
No, that's how they did it in class.
Oh,
Because
Fair enough.
so did this make sense? You can't
Yes.
just assume that the points will work with your, because they may or may not be part of the actual function. So now do partial derivatives. See, like, do you guys get the idea of them?
So
there's
this
a lot
is,
more to it.
There is a lot more, but like the simple idea.
so this objective was like implicit.
Yeah, this was finding the implicit derivative, which when we did find y prime, they called it the implicit derivative, right? Like in Calc 1 back then. So this is the method to finding it implicitly.
Okay.
By doing the whole derivative with partials, right? Then there's a formula you learn, and then they will tell you when to use it. Like on the exam, they'll tell you to do it that way.
Okay.
And then, you should get the same answer with the formula and this method if they tell you to do both. So let me make a quick mention about second derivatives. Do you guys have this copied down? Yeah. We could have second derivatives with both of them being with respect to x.
What? No. What? How
We
do do
could-
this?
Have partial derivatives with one respect to x, one respect to y. Right?
Are some of those later in the course? Is that right now?
It's right now. It was like the first day. So if we were to rewrite this with the f function, we have 2 with respect to x. Okay. Now, which one would you take the partial derivative of first? With respect to x or with respect to y?
You go backwards, it's y to
You go backwards. You do y first. It matters. And sorry.
I mean, she just stressed that she was like, make sure you're backwards.
So we take the derivative with respect to y, and the answer that we get, we take the partial derivative of that. So yeah, partial derivative with respect to y. The answer we get, we take the partial derivative of that with respect to x.
You're losing us. I'm losing me.
So
Did they see that? What does that mean?
Okay.
This is d squared f.
you can have,
Yeah, but
you know how we had, right?
Okay.
We took the partial derivative, say this time we're doing it with respect to y, because we said y here first, right? So what's the partial derivative with respect to y?
x squared 3.
X squared is a
3y
constant
squared
times 3y squared,
times.
okay?
Okay. You do a y prime, you don't do a y prime.
No, because we did with respect to y, right? Now we do it with respect to x.
Oh,
So what would that be now?
3y squared 2x or 6y squared.
Yeah.
Thank you, Danny.
So we'll do more problems and yeah.
Okay, so when you're doing, whenever you have the, like the y prime situation.
Yeah.
It's only, like, you only do it to variables that are not included in the
Yeah.
annotation.
So
So your constant variables, right?
Yeah.
Okay,
like you know how we had y primes? Because we did it with respect to x.
got it.
Like we always did the derivative dy dx.
Yeah.
Right? So this one we're doing it with y. And then we treat x like a constant.
Got it.
And then we continue on.
Cool.
But I mean it gets more complicated. But remember the idea going from left to right, okay? And then another way of writing this would be y times x. Now this is different, right? Because the first one now is the first letter, okay?
So we fixed it.
In
So you
this
have to
way,
go backwards.
yeah, in this way we
and
go
flip it
backwards.
Forwards.
But when you write with this notation, the first letter is the first one we do the partial derivative with, okay?
Let's write it that way and just write it the right way.
I think it's just a common convention they decided on.
You make me sad. You have one job. You made it look like yours.
It's just easy for it. That's some mathematical proof.
Can we do the ones where you like substitute stuff into the other stuff? It's like you have a constraint, or you have a
Constraint.
partial.
That's the last of it. That's what they did.
Yeah.
That's the
So,
We'll get to those.
okay.
We're pretty far from that right now. Let me look at this for a second.
Are we past BC Cal yet?
What?
Is we past
We're
BC
totally
Cal?
past BC Cal.
I did it! I did it! Did I do it?
Yay.
Did you say DC now?
I didn't do game cal.
Oh, really?
I had to call jumper. Yeah, I'm not.
That's crazy, Sarah. Good job.
You got a job?
Did I get a job? Oh, I'm gonna have a job in the fall. I'm a UTA.
Okay. This problem is very good at going through all of this, so we're gonna do it,
Undergraduate teaching.
but it's not like as deep.
Yay!
I'm still gonna say your mistakes.
Okay, and then he'd be like, Sarah, you're so smart and pretty. I'm so glad you're my assistant.
I'm comfortable with your mistakes.
Okay.
Slide it.
I just don't want to be a disorder. Well, frankly, it's good that we're still.
So, what would f of x be?
Say my kid.
Yes.
So how do you know? This is just taking. Is that like f sub x?
Yeah, f sub x, if you want to call it that.
So you take the derivative of x.
Yeah.
Partial of x.
By keeping what constant?
Why?
Y.
So it'd be 2xy plus 3y squared.
Yep.
Way good, Jenny.
Good job.
Sorry, I was
I did the homework.
You did?
I'm like 50%.
I'm very impressed.
F of y would be equal to what?
X squared.
Plus
Yeah.
6x.
Oh, 6x. Oh, I failed.
6xy.
Sorry. I'm a dishonor. I'm a family. Not dishonor.
Now we don't have y prime obviously here because we're doing it with respect to dy, right? So it's like multiplying this by dy over dy.
Got it.
That makes sense?
But could we do it with the dx though?
We took the derivative with respect to dy.
Yeah.
Or of f. Right? So there is no dx or partial dx in this.
So
Little
one of
problem.
our infinite variables were on top, then you start doing the implicit stuff, right?
When what?
Our independent variables, like the x, y, and z, if one was on top and there was another infinite on bottom, that's when you start doing implicit.
Yeah.
Okay, cool.
But okay. Yeah, that's correct.
Okay,
And then there's problems so where that's like a smaller step to them.
like the constraint.
Like that's I think you were talking about that or something. Yeah. So you do need to know all of this because it's leading up to bigger problems. In life. So f with respect to, let's do xx. Right? We already found f of x. So remember, we go from left to right with this. So now it's taking the derivative with respect to x again of this problem. And what would that be?
2y plus 0.
2y. Right?
Yeah.
Because 2y and 2y are constants and derivative of x is 1. Fy. Derivative of that with respect to y would be? Yep. On like the last day, I'll buy you guys pizza or something.
Oh.
Like you have to remind me that.
Okay.
That's so far away.
We'll come back.
No, last session, there's gonna be so many people there, just because you said that in the video.
That's fine. I'll buy it for like the Friday session though.
Oh, okay.
So we have to make sure it's the
And
Friday
not the
session.
final session.
Yeah, I can't afford that.
Yeah.
Send us an email.
Sure, you can, Daniel.
I'll be using Yoel's money, but
Oh, you're right. Hey, that's cool.
What?
They let you
like through a scholarship or something, or like SI money or something. But let's move on.
kind of.
Kinda.
Let's quickly look at f of x of x of x.
Oh, triple X rated. Ooh, this is getting scary.
We already found f sub x x. So what is the derivative of this with respect to x?
It's 0.
0. There you go. What's okay? Y. It's like that song, yeah.
Oh, yeah.
Okay.
Wait.
See, actually, I'm getting my mainstream song song.
So
I would get why am I in this bed? Why? Huh?
how would I write it with this notation with f?
What's called that?
X of Y.
Yep, x y. Okay.
Oh, look at you, Jenny. You're on top of it.
Did you have help CD?
What?
DE.
Oh,
So we already
Oh,
found
that's-
that. Now, what is the partial derivative of this with respect to y?
2x, 6y.
Yep.
This is just so much to keep up with. I can't even.
Okay,
So,
that's good. We should.
That's good. Okay.
You had a question?
no. That was just me, like, having a brain. No.
Okay,
nothing of green.
because I'm doing a lot of problems quickly, right?
Yeah.
I just don't.
Got overwhelmed.
Like, this
Yeah.
is easy, but it's not.
You could easily overthink it,
Yeah.
or, do anti-trade. No.
I remember like, after we did integrals for so long, we found one we had to take a derivative and I couldn't remember.
Don't say it before that.
Yep.
I mean, it went away, but,
Okay, that's that.
okay, what else did we do? There's some constraint stuff.
Now we're starting on that.
It's scary.
Is this a type, you have to do integrals in this one?
Yeah,
In this unit?
Yeah.
Why?
maybe not in this unit, the next unit.
Okay.
Because if they haven't done it right now, then it's not.
I mean, we didn't watch the videos.
But you know how we do constraints to find that? There's a way to do it backwards by doing integrals to find,
Are we gonna do?
not with the constraints, but all of them.
Okay.
Like, we do use integrals.
Are
yeah.
we gonna do partial? Is that what you're saying?
Like, we're doing partial
I
derivatives,
kind of
but-
integrated it, but I kind
but,
of.
okay.
It's kind of soft.
That would be so
Totally. I kind of, but I didn't.
Was this test hard?
Isn't it all a blur? How do you remember each specific part?
I feel like
You-
I mean, you would use it, and then you can
No,
use it.
I remember events very well. Not necessarily, like, if I have to remember like material or something, then I really do need to study. But if it's like events, I can remember them better.
Okay.
Don't teach too much while I have to go to the
Okay, let's do that chain rule. You guys want to take a break or something?
I mean,
Okay.
it's
We're gonna do the
recording,
chain
so-
The video's recording, but they can always skip it.
Oh, that's true.
All
I'm
right.
not gonna wait until Sarah gets back to channel.
Yeah, till Sarah gets back, we'll
She
start.
really wants to.
Wait, so we're taking a break.
Till she gets back.
It's on the internet?
No, the stuff that I got back in. He hasn't even sent it out. has he?
Oh, there is something.
Is it raining?
It stopped.
Are you leaving?
Yeah.
Yeah.
When I come down, when I'm not
Oh,
looking over.
yeah.
Why are you leaving? Oh, okay.
I know.
They were. So you gonna miss being an SI person?
Yeah, I'll be back. But you guys are gonna be on co-op. Right? So this is actually our last semester together.
So you're doing Calc 1, you're gonna work your way back up to the freshman.
What-
Bye, Daniel.
So are you gonna like start back with the freshman fall? Oh.
I'll be on co-op then. See ya.
Bye.
But like, this is my last semester with you guys. You know?
Yeah, it's crazy. And then there was 5. That's how it works.
Well, with ASU, I'll have one more semester.
Of what?
ASU.
Of talent.
No, like,
School while you guys go on co-op.
Oh yeah.
because they alternate, like, I'll be alternating and you'll be alternating. So then we'll never have the same. Because I'm not doing masters. So.
Me neither.
There's no need to be part of that subject. Just need school. So your co-op is how far away? It's
Oh,
small,
is it
right? Wow.
Is it over?
No, we were waiting for you.
Oh, thank you.
Where did Jin Chao
I
go?
hope that I stopped.
Did you walk out?
His name is Charles.
Charles?
Did
Okay.
you walk out?
Yeah, he's good at that. He'll be back in a minute.
Okay.
Oh, today's taking a lesson.
Wait, what time is it?
Start time.
It's hard for you to watch.
Oh.
Did you like?
Okay,
the-
you guys can start. I'm gonna pull up my car right here.
Did you like the gift I sent you?
Oh,
You
Yeah.
you just replied for number 4.
You guys can start.
no, I did that today, right?
Yesterday.
Very, was it yesterday?
Huh?
I was gonna reply something, but then it was like, I was busy, so I was
Oh,
like,
it's okay.
I should tell her quickly.
That's okay.
So how's your summer been so far?
Really busy.
Oh,
I've been going to lab every day almost.
what lab?
Yeah,
Oh,
research.
research.
Yeah.
That sounds like
He's
fun.
going to come to his own.
Oh gosh. What'd you think of your chem labs? Once I hit 208, I started like hating them.
They were annoying because it depends on your TA and sort of a thing.
Exactly.
So I had a good TA for 208 or 209.
My 208 guy, he was so chill. He didn't really care. He's like, I need a PhD here. I really don't care about y'all.
Thank you.
Oh, you got it, Matt. Charles, you didn't have to do that. Oh my God, Charles.
Yeah, if I just bought me something like that.
I got you a cookie. Aw, Charles.
Just a cupcake.
You got me a cupcake. Thank you. Thank you so much. Charles. And you're gonna put card. Oh.
We got that on tape.
Oh, really?
We'll go down to YouTube history.
Okay.
That's the
I guess because when I was driving, kind of shaky, and then
That's
kind of
okay.
fall on the sides.
That's okay. Okay, there we go.
I'll choose you.
Why did the chicken cross the road? Because chickens are really, really stupid. Oh. Oh, Charles, this is so, oh, look how cute. Oh, Charles, this is so sweet.
Daniel's just like,
Thank you,
oh my
Charles.
God.
You're welcome.
No, it's fine. What is Eshu gonna do? Like, just leave his car outside?
He's moving, but there he is.
His name is Ashu, not Ashu.
Ah, shoot. Eshu is a girl's name.
Oh,
That's
really?
fine.
Is the girl's name?
Yeah.
There you go.
Does that mean something? Daniel told us it's a joke. Sorry, Ashu.
So
Someone got me a cup.
Oh. I don't know.
yeah, Ashu is like a short form for a girl's name.
Oh.
But
I
Ashu.
said a shoe. Which
Okay, so
Sure.
this is the chain rule.
The exploration day is Monday, so.
Okay, I would eat it with some my dad, promise.
There you
okay, start breaking up. Chain.
go. So if we have a function that is in terms of u, like it has variable u in it, we need to know, and then we have u in terms of x, right? So if we want the derivative of f with respect to x, they just use normal symbols, but this is like re-explaining the chain rule, but the same principle stands. The derivative of f with respect to x, we take it with respect to u, df with respect to u, and we multiply it with du dx, right? So then we get the derivative of f with respect to x. That same principle carries over. Now, say that's the chain rule, and then they show something like the tree, right? You don't need to really understand. You never have to draw a tree, or I don't think you ever do. And it's just a way of thinking about it. We want df with respect to t. Okay. T is a function of x and y. Sorry.
Yeah, I really eat.
We want, sorry, so f is a function of x and y, right?
Yeah.
X is a function of t, y is a function of t.
Is it down or is it regular dt?
It's regular,
Okay.
right? So the way we do this is, let me draw, yes. So there's two variables, right? So there's two branches that come off of the function f, which is a dependent variable, that go to x and y, and both of them go to a t, which is our independent variable, and these are our intermediate. The terminology isn't important. But like it's important to know what your independent is. So in this case, it is t. Okay? To go, since f is a function of x and y, right? We just want it to go to x, not with y, right? So to do that, we do the partial derivative of f with respect to x. Okay? Because we just wanted to go with in terms of x, not including y. To now go to y, we do the partial derivative of f with respect to y, not looking at x. Okay, so x would be a constant here.
Would it be correct to do the f with the subscript x?
Yeah.
Okay.
Now we go from x to t's by doing the derivative, the partial derivative of x with respect to t, and then y with respect to t, right? Now we have a connection of doing the derivative, the full derivative of f with respect to a t. Like this path leads us there. Well, here they don't need to be partial derivatives because that's the only variable in y and x, right? X is only a function of t, so it doesn't matter if you write partial or full. I think full would be the correct way.
Oh, it's not partial?
No, because there is no other variable that is a part of x,
yes,
right?
okay.
It's only in terms of t, so they would be equal. Okay? Then we just combine them. So the full derivative of f with respect to t is the partial derivative of f dx, the partial derivative, times the full derivative over dt. Now I'm saying full, but that's just because it's only in terms of t, right? It doesn't play a role. And then plus the partial derivative of f with respect to y times dx dt. sorry, dy dt. So now we have the partial derivative of f of t, partial derivative of f of t. If we add them, we get the full derivative, right? So this was a partial derivative involving the x term. This was a partial derivative involving the y term. Since f is a function of x and y, we add them to get our full derivative of df dt.
So the chain rule of the partial derivatives can get you your full derivative?
Yeah.
Okay.
This is the tree method, but it's the same thing as a, chain rule.
Alright.
The reason I drew the tree is because it makes you see that there are two aspects to f, an x and a y, and that's why they use the tree as well, I believe. So if there were three variables, you'd have another branch going like that, right? Saying this was z. So you'd have partial, so f of z, dz dt. So then in here you'd add f of z, dz dt. Right? If it was another variable in the, if f was a function of another variable. Let me open up the next dyno. Did that make sense though? How we combine them? Or we do each part and then add them? Okay. I could do a problem, but do you guys get this idea? Like, I can move on. I'll make up an easy problem with it. We'll just do it in terms of x and y. F of x is equal to x plus y. X is equal to t, y is equal to 2t. Okay? We want f in terms of d, so this is equal to, what is the derivative of f with respect to x? 1, right? Because y, the derivative of y would be 0 with respect to, because we treat it like a constant, right?
Oh, yeah.
Y would be a constant, so just the derivative of x is 1 times dx dt. That would be 1 plus derivative of f with respect to y, again 1. Dy dt would be 2 in this case. So this would be 1 plus 2 equal to 3.
When the answer is 1 plus 2 equals 3.
Okay. Let's move on to the implicit derivative that we talked about before. Now let's find the actual formula for it. So we have f in terms of x, y. Again, x is of t, y is of t. I guess we are doing that. Where f of xy is equal to a constant. So rewriting rewriting it. So df dt, full derivative, is a partial derivative of f with respect to x times dx dt plus the partial derivative of f with respect to y dt equal to a 0. So this was like the problem with the negative, with equal to 5. You know how we found dz dt? So we are in this case finding dy dt. So we're going for that. In this case, I have here, sorry, this is dy dt, right? In that other one, we've tried to find dz dx, right?
Yeah.
Because we were doing the whole thing in terms of x. So in this case, imagine t is equal to x, right? We're actually trying to find df, the entire derivative df dx, okay?
Whoa, wait, why'd you just? How can you just change it? Right? Am I wrong?
It's like, don't think of it as changing. It's like in the entire time we were trying to find the derivative of it with respect to x. But it's easier to see if I had first shown it to you with a t. Okay? So if t is equal to x, in the entire problem, we're trying to find the full derivative of f with respect to x, right? But we know that, so then we do the partial derivative of f with respect to x, dx dx. So x is a function of x, y is a function of x,
X equals
plus the derivative function with respect to y plus dy dx. So in trying to isolate dy dx, this here is equal to a 1. Okay, right?
Yeah.
So don't look at this part. This is our equation. This equal to a 0, right? So isolating that, we have to subtract dy dx is equal to minus, I'm just going to write it like this, f of x divided by f of y.
Is that set like cheap way?
Yeah, this is like, so if you're ever given a problem like x squared y plus y squared x equal to 0, and you want y prime, you can go do that. Instead of doing the partial derivative of this with respect to x times dx dx plus the partial derivative with respect to y times dy dx, dy dx equal, so you can just directly plug in those answers. Did that make sense? So what would the partial derivative of this with respect to x be? 2x y plus y squared, right?
Yeah.
That's negative, divided by, with respect to y, x squared plus 2xy.
I'm sorry. On the f subscript x, does that mean we keep x as a constant?
No, we keep y as a constant.
Okay.
So in this, we keep x as a constant. So this would be your answer.
Perfect.
So this is the way quicker way using this formula than doing this. I mean, it's the same thing, but it's just one step less, right? Because we know they're going to end up being subtracted to the other side divided by the other term, right?
Yes.
So this is the implicit function theorem. And on the exam, you may be asked to derive that.
No.
I think so. I think they said you may be asked to derive it. But
Crap.
this is all you will need to write, though. I think,
That's the top part.
like, you don't need to write it with T.
Okay.
Don't quote me on that. Once I see the old exam,
Okay.
I'll know. But,
Yeah.
and I forgot to pick up the old exam.
Yeah.
I'll go and get it after this.
Can Tyler still be there?
He put it outside his room,
Oh,
so I can just go get it.
So I can just
Let's
go
go,
there.
You guys will beat me to it.
I don't feel like, oh, I really don't actually want this. Here you go, James.
Yeah, like, I'm not gonna look at it.
I really don't want another calc exam, thanks. We're gonna have taken like 60, right? I think like 50 harder in my courses. 60 calc exam.
This one has like 9.
Okay,
Yeah.
yeah, 15, 15. Another, oh, there's 15 exams in DE or not really?
It's only 2 credit hours. There's one every other week or something.
But apparently it's a lot of work.
And
Like you
all-
don't have, when I had it, it was an online homework. With Thompson, we had to write out solutions. It was like show your work, and they collected one of the problems
And then they graded it on whether you're right or wrong.
on that one problem.
Yeah.
Oh, so you like do all the problems, and you just draw a random problem.
Yeah, it was a sheet. Like I didn't have Tyler Ralston. You guys will have Tyler Ralston.
What about Robinson?
He's not going to be teaching it. I think it'll just be Tyler Ralston.
No, there's one other teacher because they have EH, if Ernst, and then somebody else has JV 100.
On like the
exams, like
schedule, it might be them. Yeah.
Were they hard? Like, were they like Dr. Tyler's exams hard? Like, or what?
Yeah.
Other okay.
I mean, DE is considered the easiest in my mind.
Yeah.
The easiest of the calcs. People don't include it because they just 1, 2, or 3. But I thought DE was the easiest. Like there's a lot of stuff that you just have to accept in DE.
And not care.
Yeah. But if you accept that, then like Lagrange's theorem and stuff, like
I
you
thought I'd say LeBron's theorem.
like you get a table and you just look at it.
I won't follow LeBron's theorem.
I know, right?
Okay. So essentially that's the main idea. I mean, you could have X be in terms of 2 variables, in terms of R and S, right? But then if we wanted with just
One of them?
one of them, we do with one of them, right? We don't even care about the other one.
Like,
So like we do like function of F with respect to R, so we don't even care about the S. But you could do both problems.
is the constraint just these other equations that you wrote besides the main equation? it's
So,
like f of x,
We
y
still
equals-
haven't done a problem where you're using the constraint yet.
Oh,
This is to find, because the variables X and Y are constrained by this function, right? So anything with f of X and Y is constrained by that equation. But we're getting there.
okay.
But if you guys have understood with me thus far, that's very good. That's like a lot of the stuff. Because now I'm just skipping some stuff on the notes, because if you understand the theory behind here, you don't need to know. And then you guys have dyno videos, I'm sure.
Yeah, we're supposed to watch them.
Oh, you haven't watched it yet?
Well, because we had 2 exams today.
Oh, yeah. I watched one.
Way to be a good student.
I haven't.
Oh, you had it.
No.
Oh, I didn't know you had.
So correction
Oh, okay.
explain why.
Charles said if you can't go to sleep, try and watch the video.
Oh gosh. I watched the Jackson.
But Charles is.
I keep all the try watching testing videos and I literally fell asleep in my bed. It's bad.
Okay, let's do this. This is what AV equals nRT. Like We were supposed to stop at 5:30, but we're
Well,
gonna
we can do this for 5 minutes and then leave.
like this problem is good, and then we can stop afterwards. Okay. So, I think they used the letter U. U is a function of t. Okay. Our constraint that combines these, EV equals nRT. Okay? N is a constant, so it can just stay there. If we want now this was the day when my dyno was not working and I had to write stuff on the little side notes.
That's a drill bit there.
So if we were to do the full, or I use the partial derivative symbol, but I don't think it really matters. With respect to p, okay, we write out the entire thing. So taking the derivative of u with respect, I'm going to write out. So this is like, we could write that symbol, but the proper symbol is f of u. Like this isn't the proper symbol, but it's like the easiest one to write out everything. F of u, taking the derivative of p with respect to p, okay, plus, I did that actually wrong.
No.
This should be f of p,
Oh.
because it was partial of u with respect to p, right? So it's f of p. So then we do f of v with partial of v with respect to p, plus f of t partial of t with respect to p. I think I did that, or did I do that backwards? No, that should be right.
Yeah.
Because this would have a partial with the denominator.
So our constraint here is the gas law.
Yeah. So this would be equal to a 1 here, right? Now, say we were holding v constant, okay? So in the problem, they tell you rho u with respect to p, holding v constant. Okay? So this is with all the variables independent, right? So equal to f of p.
Yeah.
This would just be 1, right?
Yeah.
Now, what is rho v with respect to p?
0.
0, because we're holding v constant,
Yeah, we are.
plus 0, and then plus f of t times rho t over rho t. T is equal to what?
What?
PV over NR, right? If you solve for t, yeah. T is equal to PV over NR. Are you leaving?
Yeah.
See it? Taking, do you guys see this? Like, that's what T is equal to. Taking the derivative, partial derivative T with respect to P. That would be V over NR. Because all of those would be constants. So then you plug that in here. If you know your U, you can do this part, and you can do this part, and then you have your answer.
What is it? What do I need to know?
If
Oh,
they give you,
a function of u.
Yeah.
You just, okay, so f to p, is that where I take the derivative of whatever that function is with respect to p?
holding everything else constant,
Okay.
do it with T, and then we know our rho T,
Because you take it.
not
from-
rho, but
So you do the derivative of the noble gas law? Or the
Yeah.
ideal gas law?
Yeah.
Holding
volume constant.
Okay, B.
Because you actually use this stuff,
In thermal.
mathematically in thermodynamics in classes. Normally, we don't do it because the teachers just simplify things for us, but in reality, it is used. And partial derivatives are used a lot in reality. And then, do you guys understand this whole concept, right?
Mhm.
I'll say it once more. So we want the derivative of u with partial derivative of u with respect to p, right? That is a combination of its involvement with p, its involvement with v, and its involvement with t, because we have the constraint equation pv equals nRt, right? P is a function of v and v,
NRT over V.
v and t.
Oh, because N and R are constant.
But those are all interconnected. So it's like that branch, like the tree diagram. So this would be one branch, this would be the next branch, and this would be the third branch.
Do you think it's good to try and learn that, or to just not? 'Cause I'm just gonna not.
I think
Then
The
it's
tree
better.
diagram.
Yeah.
like
They said, Crush said on like problems like this, it can get weird. They said don't do the tree diagram for constraints.
Okay, I was just gonna.
Yeah. don't try to focus on it, but it does make sense in knowing that we have three variables here, so there's three terms, right? So it's like three branches. That's and then that's
It looks more like a diamond than a tree.
Yeah.
Just know that like your F's come from your main your F's come from your main function, and then your partials come from your constraint.
It's like the chain rule, essentially. If you look at the chain rule method that explains it, it's like that too. Like this is
Your Crush is
f over p, that's p over p. So you have it in terms of f over p. But so you have your three parts, and then each of them have individual function of f with respect to that variable, and then that variable with respect to the variable that you're taking the derivative with respect to.
So far, it's always been where one is 0, and one you gotta find out.
Well, right here we could have made v a constant, right?
Yeah,
Let's make t a constant.
that's what I'm saying.
So then
Just T or both?
both of them in this case.
Oh.
So
Then
you
what
have that,
Then
right?
what do?
It's just taking the partial derivative with respect to f. I mean with respect to p. Like there is no other part. Like this is
Because
it.
the T goes away.
Yeah. Like normally when we mention this, like as I've been telling you guys before.
Alright, okay. So in that case, without the B and T, you hold B
You
and
have-
T.
You don't actually hold v and t constant. You write out everything involving that, right?
And then you decide what to get rid of?
Yeah.
Oh, okay.
But they will tell you which one to hold constant,
Okay.
right? Or they may not, and you have to work your way for all of it.
And on the test, we wouldn't be required to do all three variables, would we?
No.
Okay.
I don't think I've ever been.
That would be a lot.
Because then they would need to give you all the information.
So now in class, they did all three, right?
I don't know. I just call
Four variables.
They want four.
Yeah, that's the one example that four variables.
Okay, we are going to end it there today for
Okay,
you guys.
Thank you very much, Anna, for spending
So
your Friday afternoon with us.
make sure you guys understand this and come to that side.